Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, let's continue the chapter real numbers, and this is 9th period. And another important point is we are in the last part of this chapter. In this part, we have been discussing about two important concepts. One is revisiting irrational numbers. It was already covered in yesterday's class by proving many numbers as irrational numbers using the method called, what is that? Contradictory method. Yes. And this part is very important in the examination point of view, because every year either 2 marks or 3 marks questions will be asked from this concept. And another important concept is revisiting rational numbers. Dear students, we know that rational numbers can be expressed in decimal form. Yes or no? Yes. If it is so, in how many forms? There are 2 forms. Then what are those? First one is, it can be expressed as terminating decimal expansion, or second one is non-terminating recurring decimal expansion. Right? Now let me ask you one simple question. Is it possible to decide the given rational number has terminating or non-terminating decimal expansion, non-terminating recurring decimal expansion without actual calculation? Yes, you are right. Then how? Yeah, there is a condition. Suppose. Now let me go for explaining those conditions. Just we should go for recalling them. What is Q? Q is a rational number. Of course, it can be expressed in the form P by Q. In P by Q form, if Q is of the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers, then the decimal expansion of the number is terminating. Clear? Next, another important point. If Q is not of the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers, then the decimal expansion of that number is non-terminating recurring. And one more point, the given rational number, it's not in P by Q form. The given rational number is given in decimal form, it terminates. If it is terminating, of course it can be expressed in the form of P by Q. And when you find out the prime factorization of Q, it will be in the form 2 raised to the power m into 5 raised to the power n. Clear? These are the important points what we discussed in yesterday's class. And we started exercise 1.4. The first question was completed. That is, deciding whether the given rational number has terminating or non-terminating decimal expansion without actual calculation. That was over. Now, second question is like this. Write the decimal expansion of those rational numbers in question number 1. What are those? Which are having terminating decimal expansions. Then you can just take a notebook and just go for recalling the problems that we have solved in first question. Then you can notice that in first question, many sub questions are there in that. First one, second one, 4th, 5th, 6th, 8th and 9th. These are the numbers having terminating decimal expansion. Now, we have to write those numbers in decimal form. Let me tell you how this is. This is also very important concept. The first one is, it is 13 by 3125. 3125. Now, to express that in decimal form, observe this carefully. 13 by 3125, it is equal to, we all know that 3125 can be written as 5 raised to the power 5. Yesterday when we have found out that, you might have remembered. But how to express that in decimal form? Listen, in lower classes only we have learned that a rational number can be expressed in decimal number or decimal form if the denominator term is either 10, 100, 20 or exponent of 10, right? It is 3 by 10, we write 0.3. 7 by 100 is there, we write 0.07. If it is 43 by 100 is there, we go for writing 0.43. If 43 by 1000 is there, we go for writing 0.043, right? So now the denominator should be the exponent of 10. To get that, what I am going to do is, let us multiply numerator and denominator by same number. What is that? It is 2 raised to the power 5. Understood? Here also 2 raised to the power 5. You all may be thinking that why 2 raised to the power 5? See that here power should be same. Then bases, 5 bases, when you multiply them you should get 10. Then it will be exponent of 10. Now 5 2s are 10, 10 raised to the power 5. Clear? Next, what is 2 raised to the power 5? Multiply 2 5 times. 2 into 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So 13 into 32, which is equal to 10 raised to the power 5 can be written as 1 after 5 zeros. Now multiply this. 32 3s are 96, 9 is the carry. 32 1s are 32 plus 9, 41, 416. It is equal to, it should be expressed in decimal form. See that? 416, how many digits? 3. 1, 2, 3. Remaining here 0.00 remaining 416. This is the decimal expansion of this number. Understood? Okay. Now I'll go for taking remaining. Don't go for copying anything. And second one is, it is simple one, 17 by 8. You are going to write the decimal expansion of this. You may go for dividing directly, but this method will be helpful for bigger numbers. 17 by 8, it is equal to 17 by 8. 8 can be written as 2 cube. Now could you tell what should be multiplied? Yeah, as I said, in the denominator it should be exponent of 10. If there has to be 10, then the factor should be 2 and 5. Already 2 is there, we need 5. How much? 5 cube, because power should be same, into 5 cube. It is equal to, here you have to write like this only, in vertical, because here I did not have space, so that I have written horizontally. Look here. 17 into, what is 5 cube? 125. 5 3 times. 5 5s are 25, 25 5s are 125. Next, 2 cube into 5 cube. 2 5s are 10. 10 cube. It is equal to, now multiply 125 by 17. 17 125s are, let's go further. 17 5s are 85. 8 is the carry. 17 2s are 34. 34 plus 8, 42, 4 is the carry. 17 ones are 17 plus 4, 21, 2125. Divided by, it is 1000, because it is 10 cube. Now this can be written as, see that denominator 1000 is there. It is 2125. After 2, you have to put decimal, 2.125. Clear? Next, let us go for taking one more. Third one, it is 15 by 1600. 15 by 1600. Now, 15 by 1600, this is equal to, observe, they are not co-primes, hence you can go for cancelling. 5 3s are, here 5 3s are, 15, 1 will remain 10, 5 2s are, here zeros. Next, Again, is it possible to cancel? No. 320 is there. Now you can write 320 factorization. It is 2 1s are 6 are 0s are 2 8s are 0s are 2 4s are 0s are 2 2s are 0s are then 2 10s are 2 5s are then that much. It is equal to, it is 3 by 2 how many times? 1 2 3 4 5 6. 2 raised to the power 6 times. Here 5, just one time only. But as I told that in the prime factorization of the denominator, there must be 2 and 5. 2 and 5 are there, and their power should also be same. Here 6 is there and here 1 is there. So how much I should write? 5 raised to the power 5. Here into 5 raised to the power 5. Also, this is equal to, what is 5 raised to the power 5? Already we have written there, 3125. So 3 into 3125. Next, here 2 raised to the power 6 into 5 raised to the power, here 1 and 5, it will be 6. Next, this is equal to, multiply this. Here 3 into 3125. 3000 3s are 9000, 125 3s are 375. Divided by 10 raised to the power 6. Then 10 raised to the power 6 can be written as 1 after how many zeros? 6 zeros. It's equal to, see the 3 digits are there, 1, 2, 3, 4, sorry 4 digits. Now 0.00, then remaining 9375. Understood? So the decimal expansion of 15 by 1600 is 0.00937. Now, I hope that you have understood. You should copy from here, from second question. No need to copy this one from second question. From here to here, copy this. Still we have 3 more such problems. Rational numbers whose decimal expansion is terminating. We are going to write that decimal expansion. Observe. Sixth one. 23 by 2 cube into 5 square. 23 by 2 cube into 5 square. This is equal to 23 by, see that in the denominator, which factor should be there? 2 and 5. Already they only are given. Next, power should be same. Here 3 is there, here 2 is there. 2 cube into 5 square. Then what should be multiplied? Yes, you are right. 5 raised to the power 1. Here also 5 raised to the power 1. Now 23. 5 raised to the power 1 is 5. 23 5s are 150. 23 10s are 230. Half of that 150. Now this is 2 raised to the power 3 into 5 raised to the power 2 plus 1 is 3. It is equal to 115 by 2 raised to the power 3 into 5 raised to the power 3 is 10 raised to the power 3. It is equal to 115 by 10 cube means 1 after 3 zeros. Now 1, 2, 3, 3 digits, 1, 2, 3, next 0.115. This is the decimal expansion and it is terminating. Clear? Next, observe. Here I'll write next one. 6 by 15 is there and 6 and 15 are not co-primes. You can just go for cancelling. 3 2s are 3 5s are 2 by 5. 5 in the denominator, only 5 is there. We need 2 also. Then what should be the power? So power should be 1 because to equalize that into 2 raised to the power 1. 2 raised to the power 1 is 2 2s are 4. Now 5 2s are 10. 10 raised to the power 1 is 10 only. 4 by 10 is 0.4. Next, come to this. 35 by 50. You can observe that here also 35 and 50 are not co-primes. Hence you can go for cancelling them. 5 7s are 5 10s are. Already in the denominator whole number 10 is there, therefore it can be written as 0.7. Clear up? And one more thing you can notice. Here I have written the results. The first one we have and its decimal expansion, second one decimal expansion, third one decimal expansion, fourth one that is 23 by 2 cube into 5 square. This is equal to how much? 0.115. Next, another one 6 by 15. 6 by 15 it was written as 2 by 5. Power is 2 by 5. Power is 1 and it is 0.4. Next, it is 35 by 15. It was written as 7 by 10. And 7 by 10 can be written as 2 into 5, which is equal to 0.7. Observe the denominator terms, only denominator terms with their exponential form. Here 5 cube, 2 cube, here 320. It is written like this, and here 5, here 2 into 5. Then observe the highest power of each of these. Here highest power is 5, highest power 3, here highest power 6, here highest power 2 is not there, then obviously 1, highest power 1. And count the number of digits after which the given number terminates. See that? Here highest power is 5, after 5 digits it terminates. Highest number is 3. After 3 digits, the decimal expansion terminates. Then, here highest power is 6. After 1, 2, 3, 4, 5, 6. After 6 digits, it will terminate. And here highest power is 1 after 1 digit. Here highest power is, anyone can be taken, 1. It terminates after 1 digit. Clear? So, from this, you can just, you can make the question yourself. Suppose a number is given and it will terminate. Then after how many digits it will terminate? How do you decide? You will find out the prime factorization of the denominator, and in that 2 and there may be only 2, or there may be only 5, or there may be 2 and 5. You have to see the highest power. Then how much power will be there? After those many digits it will terminate. Clear? Just I will give you one example. 7 by, it is 2 raised to the power 7 into 5 raised to the power 11. Could you tell after how many digits it will terminate? Yes, after 11 digits. After 11 digits it will terminate. You can also check that. Similarly, 11 by, it is 2 cube into 5 square. After how many digits it will terminate? It will terminate after 3 digits. You just check that. 11 by 2 cube into 5 square. What should be multiplied? 5 raised to the power 1 into 5 raised to the power 1. 11 5s are 55. 2 cube, here 5 cube. So it will be 10 cube. 55 by 10 cube. 10 cube is nothing but it is 1000. Now see that 0. How much you will write? It is 55 is then 0.055. Clear? So after 3 digits it will terminate. This is how we can go for deciding after how many digits the decimal expansion of the given number terminates. Can be given for 1. So do remember this concept. Okay. Now you are going to copy from there to here. Copy that. Observe. Now let's move on to the third question. Just go through this. It is, the following real numbers have decimal expansions as given below. See that. These are the numbers. First one 43.123456789, and second one 0.120, 1200, 123 times 0, 124 times 0, and so on. And here also they have given one more These are the decimal expansions. In each case, decide whether they are rationals or not, whether they are rational or irrational. If they are rational and of the form P by Q, what can you say about the prime factors of Q? Got it? Yes. If they are rational, let us go for writing them in P by Q form. Then after that we shall decide the prime factors of Q. First one, observe this. Please don't go for writing anything, just keep observing. 43.123456789. This is a decimal number. Now you have to tell whether it is rational or not. We have already come to know that if it is rational, the decimal expansion will be either terminating or non-terminating recurring. If it is irrational, there will be decimal expansion will be non-terminating, non-recurring. Now you see that here in the decimal part there are countable number of digits 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits are there. So we can say that it is terminating. It is terminating or the given number terminates. Terminating. Therefore, the given number is what do you say? Rational or irrational? It is rational. Answer for first question. Second, if they are rational and of the form P by Q, let's go for expressing that in P by Q. Look here. 43.123456789 can be written as 43.123456788 divided by, see how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 10 raised to the power 9. Because 1 after 9 will come, that can be written as 10 raised to the power 9. So this can be written as 43.123456788 can be written as 2 into 5 whole raised to the power 9. So nothing but 2 raised to the power 9 into 5 raised to the power 9. Clear? Next. What can you say about the prime factors of Q? Now, the prime factorization of Q is 2 raised to the power 9 into 5 raised to the power 9. Right? So then you can say that the prime factors are 2 and 5. Clear? The prime factors of the Q are 2 and 5. That means now it is of the form 2 raised to the power m into 5 raised to the power n. Clear? Therefore, Q has 2 and 5. Next, come to second one. 0.120120012 times 0 and so on. Whether it is terminating or non-terminating recurring. Firstly, it is non-terminating because there is no end at all. There are no countable number of digits. Uncountable number of digits are there. It is non-terminating. Non-terminating, whether it is recurring or non-recurring. See that here 120 one block, but next not 120 12000 is there. So we can say that non-repeating or non-recurring. Repeat. Therefore, the given number is irrational or rational? Is irrational. Clear? Okay. Now come to third one. 43.123456789 bar. We know that bar indicates the repeating block. So this is the repeating block. We can say that it has non-terminating recurring decimal expansion. It is non-terminating recurring decimal expansion. Therefore, whether it is rational or irrational, yes, you are right. Therefore, it is rational. The given number is rational. Understood? Okay, now if it is so, it should be expressed in the form of P by Q. How do you go for expressing that in the form of P by Q? Let's go for writing that. 43.123456789 bar. You just go for recalling 9th standard concept. There is shortcut method and also the long method. I'll teach both of you. You may consider this as x. Then what should be multiplied with x? It is 10 raised to the power 9. Why? 9 digits are there. 9 digits are being repeated. So 10 raised to the power 9 x, it is equal to, it is, when you multiply 10 raised to the power 9, it will be 43.123456789 and so on. That is bar. Call it as this as statement 1, this as statement 2. Subtract 1 into, then I can write x is equal to, it is 43.123456789 bar. On subtracting, see that 10 raised to the power 9, that is 100 crore. 1, 3, 6, 9. One should be subtracted. How much you will get? It is 9. How many times? 9 times. You will get into x. This is equal to, now these get cancelled. You will get 9 minus 3, 6. It is 4. Next 7, 6, 5, 4, 3, 2, 1, 3 and 4. This can be written as x is equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6 whole divided by 9 times 9 should be written. Understood? Then what do you say about the prime factors of, what can you say about the prime factors of Q? See that these are all the multiples of, it is the multiples of 3 and 9, and when you go for dividing that, you won't get 2 and 5. So you can say that Q, it is equal to 99999, that is 9 times total. It is not of the form 2 raised to the power m into 5 raised to the power n. And you can say that therefore Q has no prime factors. What are those? 2 and 5. Understood? Yeah. This is the last way in this exercise. Now we are moving to some of the additional problems. Dear students, you all may be observing that soon after solving problems in any particular exercise, we are moving to some additional problems. Here also, let's go for continuing. Now pause the video and copy from there to here. Copy. Dear students, now let's move on to solving some of the additional problems. Just observe. Here I have written 3 questions, and do remember all 3 were asked in the examination and each for 1 mark. So all are important. They are all just like applied questions. What you have learned, based on that only they have asked the question. Go through first one. Don't write anything, just observe. What is the prime factorization of denominator of 3.127? See, the given number is 3.127. Denominator, do you say that denominator is 1? No. Then, so first it should be written in the form of P by Q. 3.127 can be written as 3127 by how much? It is 1000. Now what is in the denominator? Denominator is It is 1000. What has been asked? Write the prime factorization of the denominator. We have to write the prime factorization of denominator. It is 1000, 2 500s are 2, 250s are, then 5 50s are 5, 10s are 5, 2s are. So now we can write 1000 is equal to 2 raised to the power how many times? 3 times into 5 raised to the power 3 times. This is the prime factorization of denominator. Okay, we won't expect all these steps. You can write it directly. Here only you can come to know. After decimal 3 digits are there. Therefore, in the denominator 1000 will come. 1000 means 10 cube. 10 can be written as 2 into 3. So 2 cube into 5 cube. But in detail information has been given. We expect only this answer. The prime factorization of the denominator is 2 cube into 5 cube. Now, observe another one. This is also very important. Find the HCF and LCM of greatest prime number and greatest composite number less than 10. Greatest prime number less than 10 and greatest composite number less than 10. Their HCF and LCM should be found out. Here I write prime number, a number that has 2 factors only, which is the greatest prime number less than 10. Greatest prime less than 10. Yes, the primes are, you can just go for listing 2, 3, 5, then 7, next 11, 13 and so on. Greatest prime number less than 10, which is less than 10. These are less than 10 and greatest one is 7. Next, greatest composite number less than 10. Here I will write greatest composite number less than 10. Composite numbers are, it starts from 4, then 6, 8, 9, 10, then 12 and so on. Less than 10. These are less than 10. 4, 6, 8, 9. In that, greatest one is 9. Now we have to find out HCF and LCM of these 7 and 9. See that HCF of 7 and 9. Then 7 and 9, do they have any common factor other than 1? No. Then what type of numbers are these? Yes, co-primes. HCF of co-primes is 1. So HCF of 7 and 9 equal to 1. If you want, you can write the reason, because 7 and 9 are co-primes. Then we want their LCM. LCM of 7 and 9. We have already learned that LCM of co-primes will be the product of those numbers. Hence, we can go for writing 7 into 9. 7 9s are 63. Therefore, HCF is 1 and LCM is 63. Therefore, HCF of greatest prime number less than 10 and greatest composite number less than 10 is 1 and their LCM is 63. I hope that you have understood. Next, let's come to another problem. It was also asked in the examination once for 1 month. Find the, I think probably the last year only, 2019-20. Find the sum of exponents of prime factors in the prime factorization of 2700. There it was given different one, but here I have taken this number 2700. I hope that the question has been understood. Find the sum of exponents of prime factors. So let's go for finding the prime factorization first. Here 2700. Now this number is divisible by either 2 or 5, even 3, 9 also. So I'll go for taking 3 9s are 27, 0, 0. Now 3 3s are 9, 0, 0. Now 3 1s are 0, 0. 100 is there. 5, 2s are 10, 0. 5, 4s are 20. Then 2, 2s are. Now I'll go for writing 2700. 2700 as, look here, 3 how many times? 3 times. 5, 2 times. 2, 2 times. 2 square into 3 raised to the power 3 into 5 raised to the power 2. What has been asked? You are going to find out the sum of exponents of prime factors. Here 2, 3 and 5 are the prime factors. Their exponents nothing but powers 2, 3 and 2. So here I'll write sum is equal to 2 plus this 3 plus this 2. It is equal to 2 plus 3, 5, 5 plus 2, 7. Therefore, sum is 7. Clear? See, all the 3 problems are important and all these will be asked just for 1 mark. Each will be asked for 1 mark. You have to practice them. Now, you pause the video and go for copying from there to here. Copy. Another important type of problem. Just go through that statement. This is, find the largest number which divides 245 and 1029, leaving the remainder 5 in each case. Did you understand? It means when you divide 245 by 5, it leaves the remainder 5. And 1029 by 5 and leaves the remainder 5. Just go through this. Yes. Just go through that. Here. 245. See, when you divide 245 by 5, remainder will be 0. Actually, this number is 249. Okay. When you divide 249 by a number, it leaves the remainder 5. 245 and 1029 are correct numbers. When you divide these two numbers by a number, you will get the remainder as 5. We do not know what is that divisor. So you are going to find out that the largest divisor. How do you go for that? As the statement is given, find the largest number which divides these two, leaving the remainder. That means in these two numbers already 5 is extra. Hence, I go for subtracting 5 in these two. 245 minus 5. It is equal to how much? 240. And 1029 minus 5 is equal to 1024. Now, these are the two numbers, 240 and 1024. These are the two numbers which are divisible by a greatest number. What is that greatest number? To find out that, you should go for finding HCF of these two. Look here. Largest number or greatest number. Largest number which divides these two, 240. Largest number which divides 240 and 1024. It is to be found out. It is nothing but HCF of these numbers. 240 and 1024. You know how to find out that. Let us go for finding prime factorization of both. 240. You can go for either EDL method, Euclid's division lemma, or fundamental theorem of arithmetic. Anyone. Here 2 1s are 2 2s are 0s are 2 6 are 0s are 2 3s are 0s are 3 10s are and 2 5s are. Here next 1024 is there. Let us go for this. Here 2 5s are 1s are 2s are. Then again 2 2s are 4, 1 will remain 11, 2 5s are 10, 1 will remain, then 6. 2 1s are 2s are, 1 will remain 8. 2 6 are 4s are, then 2 3s are 2s are, 2 1s are 6 are, 2 8s are, 2 4s are, 2 2s are. Now here I continue this. It's equal to here 240. What is its prime factorization? 2. 2 how many times? 1, 2, 3, 4. 2 raised to the power 4 into 3 raised to the power 1. Next 1024. 1024 equal to 2 how many times? See that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 raised to the power 10. We want HCF. HCF is equal to, now common factor, it is 2. Whether should we take least power or highest power? Least power. Least power is 4. What is 2 raised to the power 4? 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 is the largest number which divides. 16 is the largest number which divides these two numbers, leaving the remainder 5. So here 5 is also clear. So conclusion, therefore the largest number which divides these two, leaving remainder 5, is 16. The largest number is 16. Even you can go for checking also. How? Means the given numbers are 245 and 1029. When you go for dividing those numbers by 16, you will get the remainder 5. Just for the sake of information only, I am going to divide. Observe. 245. Let us divide this by 16. 16. Ones are 16. How much will remain? 8. 85. Carry down 5, it becomes 85. 16. 5s are 85. What is the remainder? 5. Clear? Okay, next. Another one. 1029 is there. It is again divide this by 16. 16 how much are? 16 5s are 80. 16 6 are 96. Then how much will remain? 6. 69. Then 16 4s are 64. What is the remainder? Again 5. Clear? So this is how we have to find. The same type problem has been given here, just for homework. This is for homework. Observe. Find the largest number which divides 78, 178 and 228, leaving the remainder 3 in each case. That means you are going to find a number when that number divides these, it will give the remainder 3. So what is the first step you are going to do? Remainder is 3. Hence this is to be found. This is to be subtracted in each number. 78 minus 3, 75. 178 minus 3, 175. 228 minus 3, 225. Then you have to find out HCF of all the 3 numbers. Your final answer will be 25. Even I have given hint also. Please try this one. So now pause the video and start writing from there to here. Now we have another interesting type of problem which resembles the previous problem. Just observe. 6th one it is, find the largest number which divides 2053 and 967 and leave the remainders. Use the remainders of 5 and 7 respectively. What does it mean? There is a number. From that number, you will go for dividing 2053. After dividing, it leaves the remainder 5. From the same number, if you go for dividing 967, it leaves the remainder 7. Then what is that number from which these two should be divided? Is going to be found out. Clear? Now, here it leaves the remainders 5 and 7 means 5 is extra in this number, 7 is extra in this number. Hence, we shall go for subtracting first. The given number is 2053 and you are going to subtract 5 because after dividing, it gives the remainder 5. So how much it will be? 2048. Next, another second number is 967, and 7 is already extra in this. On subtracting, you will get 960. If you want to find out the largest number which divides, largest number will be HCF of these two. Largest number is equal to HCF of 2048 and 960. Now let us go for finding that number. 2048, just go for finding the factorization. 2 1s are 0s are 2s are 4s are, right? Then 2 5s are 1s are 2s are 2 1 2s are 1 will remain 11, 5s are 6 are 2 1s are 2s are 8s are 2 6 are 4s are 2 3s are 2s are 2 1s are 6 are 2 8s are, then 2 4s are, next 2 2s are. How many? 1 2 3 4 5 6 7 8 9 10 11. See that just in the previous problem we had come to know 10,024. It is standard value, can be remembered easily. That is 10 raised to the power 10 into 2, 10 raised to the power 11. Sorry, 2 raised to the power 11. So here it is 2048. It is equal to 2 raised to the power 11. Clear? Next, another number is there, 960. It is, now it is divisible by 3. 3 3s are, 2s are, 0s are. Now by which number? 2s are. 2 1s are 6s are, 0s are. Now 2 8s are 16, then 0s are. 2 40s are, 2 20s are, 2 10s are, 2 5s are. Clear? Now see the 2 how many times? 2 3 4 5 6. So 960, its factorization can be written as 2 raised to the power 6 into 3 raised to the power 1 into 5 raised to the power how much? 1. Now let us go for finding HCF. You are going to take only the common factor. What is the common factor? 2. What is its least power? It is 6. What is the value of 2 raised to the power 6? See, 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 2s are 32. 32 2s are 64. Therefore, we can write the largest number which divides these two numbers and leave remainder 5 and 7 respectively is 64. That means when you divide 2053 by 64, you will get the remainder 5. And when you divide 967 by 64, you will get the remainder 7. You can verify how we did in the previous problem. Here I will write. Therefore, the largest or greatest number is, the largest number is 64. Understood? Now, with respect to this, just I am giving you one homework. Look here. Here, find the largest number which divides 398, 436, 542, leaving the remainders 7, 11 and 15 respectively. Then what is that number? Here I have already written the answer, but how you are going to find it? Very simple. When you divide these numbers from that number, you will get the remainder 7, 11 and 15. So 7 is extra in 398, you have to subtract it. 11 is extra in 436, you have to subtract 11 in this. And 15 should be subtracted from 542. You will get 3 new numbers and you are going to find out HCF of those numbers. Understood? Yes. Now, you are going to copy from there to here. Pause the video and copy. Now, two more important types of problems. Just go through. Eighth one. It is find the greatest 4-digit number exactly divisible by 24, 50 and 36. Got it? The number which is divisible by these. Then what do you call these numbers with respect to the number which is going to be found out? These are divisor. Now we are going to find out dividend. Then how? Just go through that. Find the greatest 4-digit number exactly divisible by these three. That means that 4-digit number should be the multiple of these. Then how do you go for finding? Whether you go for HCF or LCM. Yes, when you go for taking LCM, you will get a number and that number is divisible by these three. Let's go for that. Here, I'll take LCM of these. To find out that, let us go for using prime factorization. 2 1s are 2s are 2 6s are 2 3s are. Next 15 3 5s are. Then 36 here 3 1s are 2s are, then 2 6s are, then 2 3s are. Let us go for writing the prime factorization of each. 24 it is 2 cube into 3. 15 it is 3 into 5. 36 it is equal to 2 square into 3 square, because 2 and 3 both are repeated by 2 times. Now let us go for finding LCM. LCM is, look here, it is common, you have to write all the factors. There is 2, there is 3, even 5 is also there. Should we take highest power or lowest power of each factor? Yes, you are right, highest power. What is highest power of 2? Here 2 is there, here 3 is there. 3 should be taken. Highest power of 3, here 1 is there, here is 2. I will take 2. Highest power of 5, it is just 1. Clear? Now see that. What is 2 cube? 2 2s are 4, 4 2s are 8. 3 square, 3 3s are 9 into 5. Now 8 5s are 40 into 9. 49s are 4. Write 0 as it is. 9 4s are 36. 316. Then do you say that it is the greatest 4-digit number which is divisible by these three numbers? No. But this is the number divisible by 24, 15 and 36. But this is 3-digit number. We want 4-digit number. How do you go for finding the 4-digit number? So largest 4-digit number. Largest 4 digits number. Number which is divisible by all the three. That is equal to. How do you go for? If you go for, you have to take the multiples of 360. 361s are 10, 2s are 3s are. If you go for taking 360 10s are, it will be 3600. Then 20s are 7200. 30s are, it crosses 10,000, right? But greatest 4-digit number, greatest 4-digit number is 9999. So the multiple of 60, what we are going to take, it should be less than that. Then how do you go for finding? See that here I'll write 9999. This is the greatest 4-digit number. When you go for multiplying by dividing by 360, it will be 362s are 720, then 9, here 7, here 2, 279. Carry down 9. It will be 2799. Then 360, how much are? 360 10s are 3600, but it should be close to this. 7 9s are won't come. 8s are won't come. You can go for 7s are. 7 zeros are 0. 7 6 are 42 4. 7 3s are 21, 25. Now it is 9, 7, 2. 279 is there. That means the multiples of 360, 360, which is a 4-digit number. It is 27. Hence, when you go for multiplying 360 by 27, 0, 27, 6 are 27, 3s are 81, 81 2s are 162, 16, 27 3s are 81, 81 plus 16, 97, 9720. So 360 into 27 is equal to 9720. Count the number of digits 1, 2, 3, 4. So this is the largest 4-digit number which is divisible by these 3 numbers. Exactly. Clear? So I'll write the conclusion. Therefore, the largest 4-digit number is 9720. Even this can be found out by trial and error method. That is, as I said, 20s are, 25s are, 26s are, 27s are. If you go for it that way also, you will get the value 9720. And one more is there. Almost it is similar to this one. Go through this. 9th one is, find the smallest number which when divided by 35, 56 and 91 leaves the remainder 7 in each case. Find the smallest number which when divided by these. Again you are going to find out the another number. That number should be divided by 35, 56 and 91. Hence these will be divisors. You are going to find out dividend. To find out dividend, you should go for LCM. Here I'll write. Look here. Let us find out the LCM. 35 is prime factorization. 5 7s are. 56. Here 2 2s are 8s are. Then 2 14s are. 2 7s are. 91. Again 13 7s are. Clear? Now let us find out LCM of these numbers. LCM is equal to, let us write prime factorization. 35 is equal to 3 into 5 into 7. 56 is equal to 2 cube into 7. Then 91 is equal to 13 into 7. Understood? Next, what is the LCM? LCM is, you have to write all the factors. 7 is there, 2 is there, 5 into 13. Should we take highest power or lowest power? Highest power. Highest power of 7 is 1. 2 is 3. 5 is 1. 13 is 1. Then again, 13 7s are 91. What is 2 cube? 8. 8 5s are 40. We have multiplied these two, then these two. It's equal to 0. 4 1s are 4. 4 9s are 36. 3640. This is the number which is divisible by 35, 56 and 91. No doubt. But what you are going to find out? You are going to find out a number when that number is divided by these three, it leaves the remainder 7. That means that number should be greater than 3640, right? So I'll write the smallest number is, it is LCM, that is 3640 plus, it leaves the remainder 7. It is 3647. See that? You can check that when this number is divided by 35, gives the remainder 7. This number is divided by 56, again it gives 7 as the remainder, and the same number is divided by 91 also, it gives the remainder 7. Understood? Okay. Final conclusion. Therefore, the smallest number is 3647. Got it? These are all very important. Now please pause the video and copy from there to here. Copy. Yeah. Dear students, now we are moving to another important type of problem. Even this type has also been asked in the examination many times. Go through that one by one. First one in that is, actually it is 9th one. Show that n square minus 1 is divisible by 8. If n is an odd positive integer, n square minus 1 is divisible by 8. If n is an odd positive integer, you may go for taking the odd positive integers like 3, 5, 7, 9 and so on. See, 3 square is 9, 5 square 25, 7 square 49, 9 square 81, n square minus 1. So minus 1, 9 minus 1, 8. 8 is divisible by 8. 5 square minus 1, 25 minus 1, it is 24, divisible by 8. Similarly, 49 minus 1, 48. 48 divisible by 8, that is 8 6 and so on. Now this is going to be proved with logical steps. Observe. Show that n square minus 1 is divisible by 8 if n is an odd positive integer. Let's go for proof. Then how do you write the odd positive integer? Yes, it is, in general we go for writing even as 2q, odd as 2q plus 1, right? Here I go for taking 4q plus 1. You all may be thinking that why it is 4q plus 1. Observe. The reason is n square is given. If you go for taking the square here, it will be 4q square, but that is not divisible by 8. When you go for taking 4 square is 16. 16 is divisible by 8. Therefore, I'll write, let the odd positive integer be, what are those? 4q plus 1 and 4q plus 3. 4q plus 3 for some integer q. I hope that you have understood why we have taken these two, 4q plus 1 and 4q plus 3. Clear? Okay, now let's go for taking two cases because odd numbers are written as 4q plus 1 and 4q plus 3. Case 1. What is that case 1? Here n square minus 1 is there. Let us take when n equal to 4q plus 1. Then n square minus 1 which is equal to, what is n? 4q plus 1 whole square minus 1. This is equal to, it is of the form a plus b whole square. A plus b whole square can be written as, it is a square plus b square plus 2ab. In the same way, 4q whole square. I hope that as we have already solved many problems, we can go for writing it directly. A square, 4q whole square, 60q square. B square, 1 whole square is 1 plus 2ab, 2 into 4q into 1, 2 4s are 8, 8 1s are 8, 8q minus 1, this is. Now plus 1 minus 1 get cancelled. It is equal to 16q square plus 8q. Understood? Now I can go for taking 8 as common factor. It can be written as 8 2s are 2q square, 8 1s are into q. Now see that, is it the multiple of 8? Yes. If a number is multiple of 8, then that number is also divisible by 8. So is divisible by 8. Understood? Next, let's go for taking another case. Case 2. In this, we have to take 4q plus 3. When n equal to 4q plus 3. Then I go for taking n square minus 1. N square minus 1. N is 4q plus 3 whole square minus 1, which is equal to, apply again a plus b whole square. A square 4q whole square 60q square. B square 3 square is 9 plus 2ab 2 into 4 into 3. 2 4s are 8, 8 3s are 24 q minus 1. This is equal to 16q square plus 24q plus 9 minus 1. It is 8. Again I can go for taking common factor. So now common factor is 8. It is 2q square. This is 3q plus 1. Is it divisible by 8? Yes. Why? Common factor is 8 is there. Then it is the multiple of 8. So E is divisible by 8. Now you may call this as statement 1 and this one as statement 2. I don't have space there. Here I'll write from 1 and 2. 1 and 2. What do you go for concluding? You can conclude that n square minus 1 is divisible by 8 if n is odd positive integer. I hope that you can write the conclusion yourself. Okay, good. Now come to next one. 10th one. This is also very important in the examination point of view. It is prove that n square minus n is divisible by 2 for every positive integer n. For every positive integer n. Now let's go for proving that. Look here. N square minus n is divisible by 2 for every positive integer n. Then how do you, the positive integer, it may be even or it may be odd also. Then how do you go for, as it is divisible by 2 is going to be proved. I go for taking the positive integer. Let the positive integer be, how do you take? It may be 2q or it may be even 2q plus 1 because they are not given whether it is even or odd. Understood? Next, look here. I go for taking case 1. In case 1, when n is 2q, now we have to take n square minus n, which is equal to, what is n? 2q. 2q whole square minus 2q is equal to 2q whole square is, apply square to both, 4q square minus 2q. What is common factor? It is 2. 2 into 2q square minus q. 2 into q is 2q. Now see that it is the multiple of 2. If it is a multiple of 2, it should also be divisible by 2. So I can write is divisible by 2. Understood? Next, let us go for taking case 2. In the second case, I am going to take 2q plus 1 in place of n. When n equal to 2q plus 1, then n square minus n is equal to, now here I will write 2q plus 1 whole square minus of 2q plus 1. Now this is of the form a plus b whole square. I have already written a square plus b square plus 2ab. A square 2q whole square 4q square. B square, that is 1 square, is 1 plus 2ab. 2 into 2q into 1. 2 2s are 4. 4 1s are 4. 4 into q, 4q. Multiply minus with both the terms. Minus into 2q, minus 2q. Minus into plus, minus 1. Now minus 1 plus 1 get cancelled. Now it is 4q square. What is 4q minus 2q? It is 2q. What is common factor? It is 2. 2 into 2q square plus q. Again it is the multiple of 2. Hence it is divisible by 2. Divisible by 2. You may call this as statement 1 and call this as statement 2. So from 1 and 2, we can conclude, or we can say that, conclude that n square minus n is divisible by 2 for every positive integer n. N square minus n is divisible by 2 for every positive integer. For every positive integer 2. Clear? I hope that you have understood and you have to practice. Particularly today's problems, what we have solved, all are very important in the examination point of view. And you have to focus more on even additional problems as well. Okay, dear students, before concluding today's class, let me give you the information. In today's class, particularly we come across terminating and non-terminating recurring decimal expansions and also additional problems. In terminating and non-terminating, there is a chance of giving one question for 1 mark. And here, whatever we have solved in these problems, there is a chance of giving one question for either 2 marks or for 3 marks. You have to practice. And don't waste your time. Please do practice these as many times as possible. And tomorrow we are going to conduct the test on both mathematics and science. Whatever the last 3 days we have used for mathematics and science, that much syllabus will be considered for tomorrow's test. Okay, with this, let us stop. Thank you.